Greetings. Today we're going to discuss how to assign oxidation numbers. And let's take a look at this fellow. Leo the lion goes grr. This is Leo, and it's just a little reminder: lose electrons, oxidation, gain electrons, reduction. This will become important later. So why should we care? Well, because later on you're going to have to identify types of reactions. And one of the types of reactions is the redox reaction, which is identified by changing oxidation numbers. What is an oxidation number? Well, it's a number to keep track of electrons. It could be positive, negative, or zero, depending on how many electrons are gained or lost. And here are the rules for assigning oxidation numbers. You need to copy these rules or take a screenshot, whatever it is, but you need them. So assigning oxidation numbers or oxidation states, let's say numbers. So we're going to go give examples for them. And the first one, it is in its pure elemental form. This is number 1. An uncombined element has an oxidation number of 0, which means we're talking about copper in its pure form, which would be 0 oxidation number. Iron in its pure form would be a 0 oxidation number. Hydrogen, which is elemental as well. It's a diatomic element, but it's combined with itself, with another atom like itself. Same thing goes for nitrogen, oxidation number of 0. All right, the second rule says the oxidation number of monatomic ions equals the charge of its ion. So we're talking about, for example, again, copper, if it is a +2 charge, what we're saying is that its oxidation number is going to be +2. I should write 2 plus here. But for example, potassium, if it is an ion, it is combined in a compound, then its oxidation number is +1. So what's the difference here? These are pure uncombined, and this would be, say, with KCl, where it is combined with something, or CuCl2. In that case, plus the oxidation number of copper would be +2. The oxidation number of potassium would be +1. All right, let's look at the next rule. And let me go back for a second here. The Cl would be this would be a +1, and this would be a -1. Again, these are the monatomic ions equal to its charge. The more electronegative element in a binary compound is assigned the number equal to its charge. So, for example, if I have in a compound CaO, I assign the more electronegative element first. The oxidation number is -2. We'll get back to that in a moment. And then I know that what the oxidation number of this element's going to be. I'm kind of jumping the gun a little bit here, because later on you're going to find that the sum of the oxidation numbers of a compound must be equal to 0. And we established this before, the neutrality of a compound. If I have a compound such as FeO, and I know that the oxidation number of oxygen is -2, as we're going to find out in a second, I know then that the iron is +2 as well. So that means the oxidation number, it has to be equal to 0, or the sum of the oxidation numbers. Okay, let's move right along to rule number 4. The oxidation number of fluorine is in a compound is always -1. So we'll just determine that that's the case. For example, NaF, its oxidation number is going to be -1. And in the case of sodium, remember, we want it to equal to 0. It's going to be +1. All right, so now let's take a look at rule number 5. Oxygen in a compound is always -2 unless it is combined with fluorine when it is +2, or a peroxide. So let's take an example of that. For instance, H2O. Oxidation of oxygen is always -2 unless it's a peroxide. And in this case, what is the oxidation number going to be of hydrogen? So again, this is treated just like an algebraic expression. This is -2, so I'm going to write -2 here. And this is, hydrogen is always +1, as you'll find out in one of the rules. So I have 2 times +1 plus -2 is going to be equal to 0. So 2 times +1 plus 2 plus -2 is equal to 0. So that's how I know the oxidation number of hydrogen is +1 and the oxidation number of oxygen is -2. Let's take an example where it is a peroxide, like rule number 5 establishes. If I have Na2O2, this is hydrogen peroxide. So in a peroxide, according to the rule, the oxidation number of oxygen is -1. So let's see if we can get this to be equal to 0. All right, and 2 times -1 is a -2. And we know sodium is in group 1, as we're going to establish. It is a +1. 2 times +1 plus 2. So +2 plus -2 is equal to 0. So we've established the oxidation numbers here. All right, let's take a look at the next rule. And the next rule says that the oxidation number of hydrogen in most compounds is +1 unless it is combined with a metal, in which case it is -1. So let's say, for example, in the case of HF. In HF, we know that fluorine is going to be -1, and therefore hydrogen is going to be +1. But if hydrogen is found afterwards, we know that it's actually behaving as a nonmetal, NaH. So in this case, it's going to be -1, -1, and sodium is going to be a +1, +1 equals 0. All right, and finally, in compounds of the elements groups 1, 2, as well as aluminum have oxidation numbers of +1, +2, +3. That's pretty easy because you know that in group 1, all of those have a valence electron of 1, therefore they will form +1 ions. Alkaline earth metals form +2, so therefore they are going to have an oxidation number of +2. Finally, let's take a look at a couple of compounds to work through. Just for practice. Let's just say that we have, we did FeO already. Let's do H2S. All right. We have to look at the periodic table. Sulfur, I do remember this. Sulfide ion is -2, so I'm going to place a -2 there. And I know that -2, there's no number here, so it's just 1. We assume 1, and hydrogen is going to be a +1. 2 times +1 is a +2. So when I say +2 plus -2 is equal to 0. Let's take another example, a little bit more complicated now. Not really. Okay, CO2. Okay, CO2, a -2 charge, 2 times -2 equals -4. We want this compound, carbon dioxide, to be equal to 0, so therefore what must be the charge of carbon? It must be +4. So there it is, +4. And now let's take one that is a little tougher. Let's take this one. Fe2CO3 parentheses 3. All right, before I attack this, I'm going to kind of help you remember that there's a final rule, and the sum of oxidation numbers of all atoms in a polyatomic ion are equal to its charge. So in a compound, we're always equal to sorry, it's late at night. Okay, so in a compound, it's always going to be, the sum is always going to be equal to 0, but in a polyatomic ion, it's going to be equal to its charge. So if I have, for instance, a polyatomic ion, PO4, which you know what this is now, phosphate, -3. When I do my calculations, I'm going to say, okay, I'm going to look at oxygen first. That's always a good rule of thumb. That's a -2 oxidation number. 4 times -2, -8, equals -3. So therefore, I'm going to put x here and say, okay, so what must this number be in order for this to be equal to -3? And obviously, when you do your calculations, x minus 3, you're going to get that x is equal to +5. So the oxidation number of phosphorus is +5 in this case. All right, so let's try this last one. This one is a little bit more involved. We have a charge here. We're going to start out with oxygen. Generally, we start with the middle. We don't start with the middle compound. We start with the end compound. So this is -2 oxygen, because that's just always the case for oxygen. That's what it's going to be. And I'm going to say, all right, so I have three of these, 3 -2s. So for oxygen, I have 3 times -2 is -6. Okay, right? All right, so this is -6. Iron, from the charge here, I determined that I crisscrossed, and this became a plus. This is going to be a +3. So 2 times +3 is +6. And that works out to the total number of my charge is equal to 0. But say that I want to determine what the carbon is, which is a little bit more tricky. Let's try something a little easier here. KNO3. All right. KNO3, we're going to determine what the oxidation number of N is. So in -2, 3 times -2 is -6. Blank K, I know that it's in group 1, so it's a +1. So that's a +1 equals 0, because all compounds must be equal to 0. So what must this number be? I can algebraically solve for that, and I know this is going to be +5. So +1 +5 +6, and a -6 equals 0. So there you have it. We'll do more practice. Don't worry about it. It'll come easy to you, and we'll talk about this some more in class, and I promise you'll get this easy.